In this tutorial, we are going to discuss about limits. If we have a function, a real valued function, basically limits allow us to find the behavior of a function in and around a certain point. What it basically means is, if we have a function, so I'm just taking a function, say f of x, it's a real valued function. So if f of x is a function, and based on this definition, suppose that we have a point x equal to a. So what is the nature of the function, or what is the tendency of the function as the value of x approaches a? So basically, if we have a function f of x and the values of x are getting closer to the value a, how is the function behaving? Where is the function heading towards? That is what the concept of limits allow us to determine. Even if now it's not clear, we will look at some examples and that will definitely make it clear for you. Let's work on a simple problem. Determine the limit of sine of x at x equal to 0. So already the term limit we have just now defined here. So we are saying that limit allows us to understand the behavior of the function around a given point. What is the given point here? X equal to 0. So what is the nature of sine of x around x equal to 0? Okay. So if you are already familiar with the function sine, why don't you just plot it out? So I will do it over here. You can also do it if you have a sheet of paper with you. I'm not going to be drawing it perfectly, but we know that sine looks something like this, right? So this is how the sine curve is, and this is how it will be at the point 0, and the same thing is over here also, correct? So this is how the function sine will look like when you plot it out. So notice that at the point x equal to 0, the function is itself equal to 0. So the tendency of the function is 0, as simple as that. So as we approach the value x equal to 0, the function approaches 0, and that is clearly visible from its graph. Okay, so this was a very straightforward example. It makes our understanding of limits somewhat clear, but what if the function is a little bit more complicated? So we will see another example. Straight away you can notice that if you directly substitute the value of 1 into this function, the denominator and the numerator both just vanish. G of x. So I'm just naming this function for simplicity. So let us set g of x to be this function. So notice that clearly at 1 the function is not defined. The value is indeterminate. So how do we proceed in finding the limit? We cannot, like in the previous example, just find sine of 0 and get the limit. So for this, we first need to simplify this given function. So we know the factorization of x square minus 1, that is simply x plus 1 multiplied by x minus 1. And notice that this cancellation is not possible if x is equal to 1, because then again we cannot just divide 0 by 0. So this is only true for all the real numbers which are not equal to 1. Only then our g of x here will be equal to x plus 1, correct? So with this understanding, now you try to understand what will this function g of x approach as x approaches 1. So except for the point x equal to 1, everywhere else this function is x plus 1, as simple as that, correct? Because it can be simplified to this form. But at x equal to 1, it cannot be simplified as such. Instead of plotting it, we can do one thing, we can just try to find the values. So this is another way in which we can see the behavior of the function, right? You've put in the values and you see what the function is giving you. So let us start putting in the values. So we will put all the values except x equal to 1, but approaching 1. If you want to approach the point x equal to 1 from the left side on the number line, so all the values coming from say 0.9, 0.99, all these values are reaching closer and closer to 1, right? So I'll list them out, you just observe the pattern. Ending, so 999 keeps going towards 1, that is what we mean. Okay, so I'm taking all the values of x from the left side as such. So when you substitute these values of x into g of x that we have simplified it to, it simply comes out to be an addition with 1, right? So it becomes, okay. So as we approach the point x equal to 1, g of x is approaching 2. We can see that 1.99999 is very, very close to 2. So from the left side, it seems to be that the function is tending towards 2. Okay, so the nature of the function we can understand with this. So what happens if we approach the values of x from the other side? So what is on the other side of 1? Just take any number that is on the right side of 1, little bit close to it. So now let us approach this x from the other side, from the right side. So then what is the value of g of x? Again, simple addition. So as we are substituting the values of x from either sides, it seems that the function is approaching 2. So you can simply write down this observation. So observe my notations that I will be using from now. So as x approaches the value 1, we notice that the function g of x approaches 2. As x approaches 1, I am saying g of x approaches 2. So mathematically this fact can be written as limit as x approaches 1 for the function g of x is equal to 2. As simple as that. Notice that this is made up of two facts. First is approaching 1 from the left side and approaching 1 from the right side. So these two things are known as the left hand limit and the right hand limit. Limit as x approaches 1. So the left hand limit is denoted as such. So a minus sign above the 1, it means that we are approaching 1 from all values which are less than 1. So it's from the left hand side. This is known as the left hand limit of the function g of x. In this case, it is also equal to 2. Similarly, we also saw that the right hand limit, so this you might just come to the observation, it will be plus. So all the values of x which are approaching 1 from the right side which are greater than 1. So we are approaching 1 from the positive side or from the values which are greater than it. So this is the right hand limit for this function g of x. In this particular case, this was also equal to 2. So generally we say that limit x equal to x tends to 1, g of x is equal to 2 when the left hand limit and right hand limit both are existing. First of all, they should exist and both of them should be equal. Then we can say that limit is such. So this thing is made up of two elements, correct? The first element is the left hand limit and the second element is the right hand limit. We have just understood the concept of limit by the simple definition that was written at the top. So what was the definition that I said? The concept of limits allows us to understand the behavior of a function around a given point. Okay, then we took a simple example. So sine of x. Sine of x is defined for all real numbers. Whatever real number you put, sine of x has a value. So for such functions where you can simply substitute, obviously the limit at that point exists and it is equal to the value of the function. So how can we better generalize this fact for such functions, where it is defined for all real numbers? We can simply say that the limit as x approaches a certain point a for the function f of x, it will be equal to the value of the function at a. You simply put the value of x equal to a into the function and you will get the limit for such functions. Then we have some functions like this one in the second example, x square minus 1 divided by x minus 1. So this function is not defined at x equal to 1. For such a function, we cannot simply go ahead with our previous definition. So what did we do? We tried to simplify it slightly. We took out the factors, we tried to remove it, and we observed that it cannot be cancelled out at that particular point. And then we plugged in the values. And then what do we notice? The limit came out to be 2. So you could have simply put in the value x equal to 1 into g of x. So for such a function, which seems like it is not defined at a certain point, you first have to simplify it. Once you simplify it, the function will seem like now it is defined at all real numbers. Then you simply plug in the value at the end. You cannot just simply put in x equal to 1 into the given function and say that this is the value of that function. It's only the limit of the function. So notice that this limit is not equal to g of 1, correct? So g of 1 is not equal to 2. It's just the limit of g of limit as x tends to 1 g of x is equal to 2, but not the function itself. So this is a very important understanding. So if you are clear in this, that limit is different from the value of the function at that point, then it will be much easier for you to go forward. Okay, so now let us say, so now I'll directly use the notation because now you are familiar with the notation. Just notice the fact straight away. See that the denominator is x, and as x tends to 0, that is if you put the denominator equal to 0, what will happen? The function will be not defined. So anything divided by 0, we don't know what it is, so we say it's not defined. So now we will multiply this thing with the conjugate surd. So we know that when we subtract or add two square root terms, we call it a surd, right? And then if you want to simplify surds, what do we general practice is to simply get rid of the square roots. So how do we get rid of square roots? We multiply them with the conjugate surd. So the same term that is there in the numerator, I'm going to use that term and just change the sign in between. That is the conjugate of it. So I hope you are able to understand the simplification. In case you have a doubt, feel free to ask me in the comments. I will try to clear it, or maybe someone else will. So notice that we can cancel out the x from the numerator and denominator. And again, this thing cannot happen if x is equal to 0. Okay, so this cancellation only takes place given that x is not equal to 0. So the simplification that we are doing now is only possible for points where x is not equal to 0. The function is not defined at that point, but the limit is defined, because when we substitute the value of x equal to 0, we are getting a definite value. We are not getting something which is indeterminate. Correct? So it means that the function is tending towards a particular point that we can find out. So the limit is existing. Correct? So what I mean is the limit as x approaches, so here we are saying 0 for the function, here I have written f of x. So this is going to be equal to 2 over square root of 1 plus 0 and 1 minus 0, we are adding them, and that thing will be 2 over 2, correct? This denominator is again 1 plus 1, which is 2. So what is the value of this? It's simply 1. So the limit is 1. Okay? The limit is 1. But notice that this is, as I said before, this is, keep it in mind, this is not equal to the function at that given point 0. Okay? So f of 0 is not 1. The limit is 1. So it seems like the function is approaching towards 1 as x is approaching 0. But at the point 0, the function is not defined. That is very important. So another important definition comes out of this. So we can extend the definition that we had in the beginning, right? So we can go back to it. So what was written? The concept of limits allows us to understand the behavior of a function around a given point. So instead of putting a full stop over here, I'm going to add something to it. Or not. I am writing down what I have understood from it, and it means exactly the same what you will find in any of the textbooks that you read, where you will read about limits. Okay, so limit will allow you to understand the behavior of the function around a given point, and we don't care if the function is defined around that point, if the function is defined at that point or not. It will just help you to find out how the function is behaving around that point. That's it. So this is what we have understood till now. So if the function is defined, simply substitute. If it is not defined, simplify and substitute. And if after simplification also it's not defined, then the limit doesn't exist. As simple as that. Okay. So the limit may or may not exist. So in all these examples, I have taken them because I wanted to show you what limit means. So we will see in the next video some of the examples of functions where the limits are not defined. So see you in the next video. Thank you for watching this tutorial.